I will use conservation of linear momentum at this situation, final situation. For the initial situation, there is no velocity for the object, both objects. Then we can use conservation of linear momentum. Initial linear momentum is 0. Final linear momentum 2m into v plus m into u. But we know that velocity is in opposite direction for the 2m mass. Therefore, we have to substitute this one as a minus term. Then I will bring this term to the left hand side. 2mv equals mu. Now we can cancel out m terms. 2v equals u value is 2gh root. Now v is root 2gh divided by 2. 2gh divided by 4 root. Then getting into the square root, we have to get it as 4 square of 2. Now we can cancel out 2 and 4. Root gh over 2. Then we can get answer is 3 for the question number 21. Then 22. An elevator of weight 5000 Newton carries a load of 5000 Newton. Then total weight is 10,000. While moving vertically upward in a building, it travels at constant velocity from second floor to 12th floor in 20 seconds. The height of each floor is 4 meters. If only 80% of the power generated by the motor is consumed to lift the elevator and the load against the gravity while moving at constant velocity, the power of motor. We can consider 80% of power of motor should be equal to mgh is the work done. We have to divide by time. Then 80% of power, total mass 10,000, total weight 10,000. Then mg value is 10,000. Second floor to 12th floor. There are 10 floors. One floor, height of one floor is 4 meters. 4 into 10, 40. 10 meters, 40 meters is the height. Divided by time is given as 20 seconds. Then we can find the p value. 80% of t should be equals to mg 10,000 into 40 into time 20 seconds. Divide by 21, divide by 22. We can cancel out 1 0. Then p is 1000 into 2 into 100 divided by 8. Divide by 8 125. 250 2 zeros. 25,000 watt. It means 25 kilowatt. Then answer is 2 for the question number 22. In 23, a monkey climbs a certain vertical height along a vertical rope with uniform speed 30 seconds. Later, the same monkey climbs the same vertical height along a spiral path 75 meters. Path length with another uniform speed. If the monkey applied the same power to its motion in both cases, the speed with which the monkey has climbed spiral path is. For both situations, displacement is 75 meters. For the first situation, the height is given, height is not given. A monkey climbs in a certain vertical height along a vertical rope with uniform speed in 30 seconds. Speed is 30 seconds. Time is given as 30 seconds. For the second situation, there is a spiral path. Length of the path is 75 meters. And we have to find the speed of monkey at the spiral path. The monkey applies the same power. When considering power, power means work done per second. Then for both situations, power is constant. The work done by the monkey is the work done to increase his potential energy. Therefore, there is no frictional force in this path. It is a smooth spiral path. Therefore, it should move with the same power. It means the power in first situation should be equal to power in second situation. For the first situation and second situation, power is constant. Then we can consider time taken to move. In first situation 30 seconds, it is given in the question. It should be equal to the time taken to the second situation. Because of power is constant, its potential energy increasement rate should be constant. Therefore, time for this spiral path also should be 75. Then we can use ST equals UT for the spiral path. For the spiral path distance 75, we have to find the speed. Time should be 30 seconds. Then we can cancel out it. Divide by 15 2, divide by 15 5, 5 divided by 2, 25 meters per second. So 2.5 meters per second. Then answer should be 2 for the question number 23. This one is 22. Then 24. A weightlifter lifts a weight vertically up, positive direction, with his hands. The sign of work done by his hands on the weight, gravity on the weight and the weight on his hands respectively up. We have considered that upward direction is the plus direction. Therefore, work done by his hands should be plus. It should be in upward direction. Therefore, A should be plus. And gravity on the weight, gravity is acting in downward direction. It should be minus. Weight on his hand also minus. It also in downward direction. Plus minus minus. Then answer is 3 for the question number 24. Then 25. Consider the 4 metal balls of same volume placed on a smooth horizontal surface. The mass of the first 3 balls is m, while the mass of fourth ball is 2m. They are equally separated on the straight line. The first ball moves with speed v and collides with the second ball, resulting in a series of linear elastic collisions among the balls. After the collision, the motion of each ball is best represented by. Linear momentum should be conserved. When considering first situation, given in the first answer, there is only a linear momentum in left hand direction, but initial linear momentum is mv in right hand direction, therefore it is false. For the second situation, the linear momentum is mv, we can consider final ball mass 2m into velocity v over 2. It means linear momentum mv. It means the total momentum for the first ball before the collision has transferred to the final ball. It could not be because of the velocity. When considering masses, final ball has a large mass, 2m mass. Therefore, there should be a velocity for the initial ball in against direction. It should be rebound. For the third answer, momentum in left hand side m into 2v, sorry, v over 2. It is minus because of left hand side. Thus momentum 3v into 4 times 2m divided by 2. Then 3mv in right hand side, we have to subtract 3mv over 2 in right hand side, we have to subtract mv over 2. Then 2mv over 2, it means there is a momentum which is equal to the initial momentum of the system. But when considering collision, the velocity of the 2m mass cv over 4, m mass v over 2. When considering kinetic energy, half mv squared, I will calculate it. For the initial situation, kinetic energy is half mv squared. For the given final situation, kinetic energy half m v over 2 squared, it means v squared over 4, and half m mass 2m cv over 4 squared, it means 9v over 4. We can simplify mv squared over 8 plus 9mv over 4, it means 18mv over 8. Now we can add 18 plus 1, 19mv over mv squared over 8. This value is not equal to this one. Therefore, there is a difference between kinetic energies. Initial kinetic energy before the collision is this one. Final kinetic energy, it means sum of kinetic energies of given two moving objects. It's a different value. Therefore, it could not be the answer. When considering fourth one, I will consider linear momentum. In minus direction, v over 3 into m. In plus direction, 2m over 2m into 2v over 3. When subtracting these values, because of momentum is a vector, we can get momentum is mv. Therefore, momentum is correct for the fourth answer. Then I will consider kinetic energy, half m v squared. V squared means v over 3 squared, v squared over 3. It is the kinetic energy for the first ball. And kinetic energy for the second ball, half 2m, 2v over 3 squared, it means 4v squared divided by 3. We can add then mv squared plus 8mv squared, 9mv squared divided by 6, divided by 3 mv squared. We have to consider square. Then getting velocity squared, 3 squared is 9. Then 18 9 mv squared. It means half mv square. It is equal to the kinetic energy for the first situation, and therefore kinetic energy also conserved. Then answer is 4 for the question number 25. For the collision, kinetic energy and linear momentum should be conserved. Then question number 26. The figure shows the path AB of a ball projected from A. Neglect the air resistance. Consider the following statements. Statement A. The velocity of the ball at maximum height of the path is 0. But it is false. There is a horizontal velocity. We know that maximum point of the path, the vertical velocity is 0, but there is a horizontal velocity. Then statement A is incorrect. B. The velocity of ball at point B is equal to the velocity of ball at point A. No, it also false because of velocity of ball at A is in this direction. Velocity of ball at this place is in this direction. There are different directions. Therefore, velocity is different, but speed is same. They have given that velocity is same. It is false. The kinetic energy of the ball at point B is equal to the kinetic energy at A. It is correct because of kinetic energy depending only on the magnitude of velocity. It is a vector. Then only C is correct. Answer is 2 for the question number 26. Then 27. As shown in the figure, a sphere of mass m is released from the rim of a hemispherical ball of radius r. The sphere finally stops due to friction at the bottom of the ball after oscillating several times. Which of the following is true regarding the work done by the gravitational force and the normal reaction force acting on the sphere during the process? Work done by the gravitational force is mgr because of it is moving r height in downward direction, and there is no work done due to normal force. Normal force means reaction. Reaction is in this direction perpendicular to path, but this object is moving in this direction. Movement is perpendicular. Therefore, there is no work done by the reaction. In mgr and 0, answer is 3 for the question number 27.